Good evening, sir. Thank you for joining the program, sir.
Hope I'm audible.
Yes, sir,
Enjoy.
you're audible. You're audible.
Okay.
MC team, if you're ready, you can start the program.
Sure, ma'am. Good evening, everyone. Welcome to today's session of FDP and Mastering Research in Computer Science, jointly organized by the Internal Quality Assurance Cell and the School of Computing, DETIAS. Today's topic: leveraging AI, ML, and quantum technologies for next generation wireless communication address the cutting edge fusion of artificial intelligence and quantum computing with future wireless systems like 6G. These technologies are redefining how we design, optimize, and secure wireless networks. To guide us through this exciting frontier, we are honored to have Dr. Sabyashakshi Bhattacharya, a leading researcher in wireless communication and cybersecurity. We look forward to engaging and insightful session. Chief guest interaction. It's my pleasure to introduce today's chief guest and speaker, Dr. Sabyashakshi Bhattacharya, Professor in the Department of Electronics and Telecommunication Engineering at Barak Valley Engineering College, currently deputed to Residential Girls Polytechnic, Golaghat. Dr. Bhattacharya is an accomplished academic and researcher with expertise in wireless communication systems, AI ML for signal processing, and physical layer cybersecurity for satellite and space networks. He holds a PhD from IIT Guwahati and actively engaged in postdoctoral research on quantum and AI generated wireless systems in collaboration with the University of South Florida and Guwahati University. With numerous publications in SCI, Scopus Index journals, and presentation at global platforms like IEEE Smart Cities and IEEE Comsoc WTS, Dr. Bhattacharya also contributes as a reviewer and TPC member of the leading IEEE journals and conferences. His pioneering work at the intersection of AI, ML, and 5G 6G wireless systems positions him as an ideal thought leader for today's session. Please join me in welcome our chief guest, Dr. Satyashakshi Bhattacharya, sir.
Thank you, madam. Thank you. Thank you so much.
So you can take over the session, sir.
Yeah, surely, ma'am. So I'll be sharing my screen. First of all, good evening to all the organizers and all the participants of this international FPT that is organized by GEIAS College, the Co-Education College of Science and Arts and Sciences at Erode, Tamil Nadu. And also, it is being organized by, I believe, the IQAC cell of the institution and collaborating with the School of Computing Sciences. I extend my heartfelt greetings for the very nice and very kind introduction, and I thank Dr. Kartika once again for giving me this wonderful opportunity to interact with the participants of this FB. I'm sure the next 1.5 hours will be a very engaging session. I'm looking forward to it. I have shared my screen, madam. If you can just kindly give me a feedback that whether you are able to see the screen, ma'am. Yeah, are you able to see the screen, ma'am?
Yes, the screen is visible, sir. You should
Okay,
proceed.
madam.
You are good to keep.
Yes, the screen is visible.
Okay.
So I have turned it down to full screen now. Yeah. So once again, good evening to one and all participants to this international activity. So myself, I have been introduced already. I am Dr. Sabyashakshi Bhattacharya. I am an assistant professor in the Department of Electronics and Telecommunication Engineering of Barak Valley Engineering College, Sri Bhumi, and presently I am deputed to the Department of ETC in Residential Girls Polytechnic, Golaghat. Both these institutions are covered under the Government of Assam. So today in the lecture, basically we shall be covering concepts in connection with this FDP on two of the vital key game changers of the next generation technology. One of them is basically the AIML technology, and the other out of them is the quantum technology. Those are taking over the next generation paradigm of any sort of next generation system Here we shall be discussing more about my area, that is the next generation wireless communication, how AI/ML and quantum technologies are changing over the realm of communications in the modern world. And as I have mentioned in my title, I shall be covering both aspects of physical layer as well as higher layer perspective. So these are broadly the contents that I shall be covering. The first half of the lecture will mostly cover aspects related to how AI/ML is affecting the wireless communication, and the second half of the lecture will basically cover the second half of the lecture. Dr. Kartika, am I audible clearly? Am I audible clearly?
Yes, sir. You're audible. You're audible, sir.
Okay, madam. So the second half of the lecture
Okay.
will
So the
basically
second half
cover
of the lecture will basically
So the second half of the lecture will basically cover the quantum computation based approaches which are used in the AI/ML based wireless communication. So there are two halves to the lecture. One is related to the AI/ML based evolution of wireless communication, and the second half mostly covers aspects related to the quantum based approaches in wireless communication. So this is an interactive session. So at any point of time, if you have any sort of queries, you can directly disrupt me and you can unmute yourself and ask me the doubt. And at the end, obviously, we will be having some interaction. So just to have a context setting of basically what is there for the focus in the next generation wireless communication. So we should understand that we have basically evolved very rapidly. We have evolved very rapidly from the first generation to the sixth generation technologies, where in the first generation we were basically having aspects such as the voice call with the clunky Motorola phones with that single antenna. If all of you remember this figure, and from there we had a paradigm shift just in about 10 years where we could have the text messaging technology, and basically from the AMCS based architecture we could move to the GSM architecture in a very short span of time. And the moment GSM came into the picture, the mobile telephony was not just about transmitting the voice calls, but rather it was also about transmitting the text or transmitting the data. So it was about data communication and parallel voice communications over channels or over physical resources. And with 3G coming into the picture, we had the internet access technologies basically. So internet access technologies were basically of the nature of the WCDMA technique, the CDMA parameters. And after that, slowly we evolved to the 4G technology, wherein the long-term evolution concept came in. That is the LTE, which in computer sciences domain would lead to a stack-based network architecture as compared to 3G, where it was a non-stack based network architecture. So we could say that 4G gave us a complete internet access. But mind it that we were not yet connected. Who connected us was basically this 5G network. With 5G, we could start speaking about multiple antenna systems or multiple smart antenna technologies, which ultimately led to a smarter society with the underlying technologies being one is the MIMO architectural system, that is basically a hardware architecture or a signal processing architecture which gives higher data rates or higher capacity rates to us. And also we had the change in the radio resource, that is we had the millimeter wave frequency. From around 2.4 gigahertz of transmission, we were trying to use thicker bands which were about 32 gigahertz and ranging up to around 72 gigahertz as well. And the story doesn't stop here. From a smarter or connected society, now we are looking at a self-adjusting or a self-understanding society, which is basically an intelligent society, where we are trying to basically speak about the IoE concept. IoE concept essentially means that the Internet of Everything. So the Internet of Everything is basically the purpose of 6G, which is supposed to be rolled out by the year 2030, and we are focusing on terahertz based bands. That is, we are trying to achieve as compared to 5G, where we were already having a data rate of basically giga internet, that is 1 Gbps. We are trying to achieve 1 terabyte terabits per second of speed with the 6G technology. It is still in progress. The research is still in progress. I am basically one of the researchers in the 6G domain. So I have mentioned here under construction because the systems or the core networks as of now are under construction, and like the technology evolution is still going on. So I just thought that as a context setting, I would not be like, sorry for this. Yeah. I would not be just keeping you limited to some textual information. Rather, to make it more interesting, let us also have some multimedia component or some video. So this is one of the videos which speaks about the evolution from 1G to 6G technology. So if you can have a look at it, and hopefully you will like the video. Now, Dr. Kartika, I will be playing the video. If you can kindly give me a feedback that whether you are able to hear the audio or not.
Sir, I can able to hear your audio, but if possible, can you can be little louder?
Yeah, is the audio coming at your end?
Yeah. Is the audio coming at your end?
Yes, sir. Yes. We could hear your audio as well, sir. If possible, a little bit louder.
Okay, madam. Just
Okay, madam. Yeah.
Yeah, so now I'll be playing it once again. This is for you, the participants, everyone.
Mobile networks from 1G to 6G. Welcome
Now you
back.
can hear it clearly, right, madam?
Today we're diving into the fascinating
Yes, sir. Yes.
from those fuzzy multiplayer to crystal clear video chats, blazing fast downloads, and seamless connectivity we often take for granted. We're breaking it from the humble beginnings of 1G.
So here you can see the 1G technology phones, basically with the clunky landlines, with the clunky Motorola phones with that antenna, basically.
Until we lose signal, right? 1G, the dawn.
So this is about that Motorola phone that is I
Let's
was
rewind
speaking
back
about.
to
In
1983.
1983, basically,
The
it
world
came
said
out.
hello to the first generation of mobile networks.
That was the 1G
1G was
technology.
like stepping out of the Stone Age and into the digital age. Okay, maybe not that dramatic, but it was huge. For the first time ever.
So the
we could
landline, clunky landline phones were removed due to that.
imagine no more tangled cords or being tethered to one spot, but hold on, 1G wasn't all sunshine and roses. Remember those gigantic brick-like phones? Yeah, those were the OG mobile devices. They were notorious for their spotty coverage, dropped calls, and let's be honest, the audio quality. Let's
The
just
quality
say
of the audio and the security was
but
a
hey,
concern in
it
1G,
wasn't a start.
actually.
1G paved the way for the future of mobile
But it made a
communication,
start
and
to a
for that,
technology.
it deserves a
That is
place
the
in
modern day
the
communication technology.
2G, the texting era begins.
With 2G, we started the texting era.
This is where 2G enters the scene, bringing with it the power of digital communication. Remember those old Nokia phones with the indestructible bodies that sang pre-installed? That's 2G. This new generation of mobile networks ushered in clearer calls, better security, and most importantly, it gave birth to the short message service, better known as SMS or texting. Remember those tiny keypads and the struggle of typing out a message with T9? It was all worth it because you could finally send messages. 2G also laid the groundwork for mobile internet, but it was slow and clunky and honestly not that great. But hey, it was a stepping stone to something even bigger and better. Next up, 3G.
With 3G, the mobile internet era started.
The early 2000s saw the rise of 3G, and let me tell you, this was a game changer. Remember the flip phones and the early smartphones? They were powered by 3G, and suddenly the world became a whole lot more.
It started the paths of connectivity, the baby steps of connectivity.
On our phones without wanting to throw them to all. Websites loaded faster, we could download music, video calls started to become a thing. 3G truly
3G, we started off with some amount of video calls.
it was the catalyst for the mobile revolution, and it set the stage for the smartphone era we live in today. 4G, the LTE revolution. 4G.
This was the long-term evolution where high data rate system became popular.
Lightning fast download and upload speeds, almost as fast as home broadband connections.
Streaming services came into the picture because we also had the pandemic during half of the 4G era actually.
Gaming exploded with 4G. Remember when you had to be connected to Wi-Fi to play a game without lag? Those days were long gone.
Long streaming video games, better streaming video games became a reality.
4G enabled a seamless mobile experience. Let's be real, it's hard to imagine our lives without it. But as always, the tech world never sleeps, and there's always something new on the horizon. 5G, the quantum leap. Enter
With
5G,
5G,
the
we
next
came up
generation
across a
mobile networks. This is
total
a-
paradigm
It's
shift.
a complete paradigm shift. We're talking insanely fast speeds, like downloading a full HD movie
A
in
full
seconds.
HD
But
movie
it's not
within
just
seconds we
crashing.
are able to download.
5G also enables incredibly low latency, which is the time it takes for data to travel from your device to the network and back. This means real-time gaming,
The round
virtual
trip
reality,
delays became
and
very
augmented
less with
reality
5G.
experiences are going to be mind-blowing. 5G will also be the backbone of the Internet of Things, with billions of devices connected seamlessly, making our cities smarter and our lives more efficient. Imagine self-driving cars communicating with each other, smart homes that adjust to our needs, even remote surgery becoming commonplace. 5G is still in its early stages, but the potential is limitless.
5G is
6G,
being
the future of
implemented,
connectivity.
but
We've come a long
6G
way from
research has
those dummy
already
1G
started.
phones, haven't we? But the future of mobile is even more exciting. While 5G is just getting started, researchers are already working on 6G, and it's going to be revolutionary. Imagine speeds 100 times faster than 5G, allowing for near instantaneous data transfer. We're talking about a world where the lines between physical and digital
So
reality
basically, we are talking about
blur.
holographic
Rapid
communication.
communication
We
is
are
immersive
talking about a
virtual
translation from
environments,
physical
giving
world
ability
to
to
the
control
digital world,
devices
basically.
within our
Where you can
minds.
say the mind
That's
control mapping is being done by this
6G
future.
will be powered by
So
artificial
AI and
intelligence,
ML becomes
creating networks
inevitable
that
in
can
such
learn,
a
adapt,
situation.
and optimize themselves. It's going to be fascinating to see how 6G unfolds and what new possibilities it unlocks. And there you have it, the incredible journey from 1G to 6G.
Okay,
From those
so in
crackling
interest of
voices
time, I
to
will
the
keep the
mind-blowing possibilities
video
of the
short to this
future.
point.
Mobile.
I'll share the slide. You can go through the entire video streams actually. Dr. Kartika, the feedback about the video playing is okay. You are able to listen properly.
Yes,
Hello.
sir.
Okay, ma'am. Okay, so now the question is that with that video, we had a context setting of what actually the evolution has been from 1G till the future 6G networks. But if we consider from 5G till 6G, many a researchers will question or many a common person will question that what is the need of such a quick transition from basically a 5G system to a 6G system, because 5G is just in deployment, and why within another 8 to 9 years, that is in 2030, we are looking at the deployment of another parallel technology, that is the sixth generation of communications. Now we should understand something very carefully, that 6G essentially does not aim to have a total different approach towards the communication scenario. Rather, it uses some technologies such as AI/ML technology, quantum technology, the optical technologies to make sure that the security, or rather we should say the sustainability of the 5G networks is enhanced. So if I look at the figure by the entity review, the entity technical review on the left, then you can see the 5G is already surrounded by many technologies like the URLLC. URLLC is the ultra reliable low latency communication. So ultra reliable low latency communication basically means that the round trip delays are less than 1 of a millisecond. So basically, how much lesser delay can we receive? No, we cannot receive very less delay as compared to 1 millisecond. That is true. But the problem with 5G is, if we are using 5G packs regularly, most of you do it, then one problem is related to the reliability or the sustainability in such 5G packs, because the links of the communication, as you know, they are very very high frequency. 5G uses 72 gigahertz, 60 gigahertz frequencies, so the wavelength of such frequency is very less. And since the wavelength of such frequency is very less, so the distance that the signals, or the range of such communications is very very lesser. So if the range of the communications is less, then the reliability becomes a major challenge. Now basically 6G targets that I have mentioned in my slide, that is pushing the boundaries beyond the 5G wireless. That is, 6G would not target to achieve a higher delay rate, or what to say, a less amount of round trip latency. It would remain at 1 millisecond only. But the 5G's sustainability, it would push that. Now if we are receiving, or if we are having reliability of the link of say 1 second to 2 second with say 1 millisecond of delay, now it would ensure that reliability is increased over more number of seconds. So the 5G technology essentially will remain in its place, but the boundaries of the 5G technology will be pushed. Similarly, if we talk about the antenna technology, then already in our 5G technologies, we are having 256 number of transmitter antennas at the base station, and we are having the necessary computational model that is already in place. But the problem is the reliability of those signals. Up to how much time continuously you can get the services from such applications, and in between if there is a call drop, then the entire technology fails. So our purpose here is to increase the reliability or the sustainability of such systems basically. So that is the 5G support. 5G's boundaries are basically being pushed by 6G, and that ultra reliable low latency will now become extreme low latency, that is 1 millisecond or less, but there will be a stable low latency, and it is not that we will just receive the signal for a while and the signal will suddenly go off. So that is the basic purpose. Of course, along with that, when we are changing the band, suppose from 5G millimeter wave band, we are trying to move towards the terahertz frequency band, then also we are achieving higher amounts of data rates, more higher amounts of data rate, but that is the secondary purpose. The main purpose is that instead of URLLC in 5G, we should have the extremely ultra reliable low latency communication, where extremely means that we should have that 1 millisecond round trip delay for an enhanced period of time, and the link should become more reliable. So the diagram to the right, it basically shows what I have already discussed in the video, that is the evolution of 1G from the simple voice services through the different Gs and up to 6G, where AI, blockchain, and that type of relevant technologies are coming and are applied into the 5G network. So how they are incorporated, we shall discuss further. So these are some of the key technologies when we are moving from the beyond 5G or 5G system to the 6G system basically. So these technologies are basically what? So we should understand one thing, that when I talk about the key enabling technologies of 5G systems, it is not always that our system is a totally new system. No, we are having the previous generation technology like the millimeter wave, then the satellite communication technologies are now being revolutionized. All of us know about Elon Musk's SpaceX revolution. So that was entirely satellite communication, but the new era satellite communication, where entire communication was taking place in the lower Earth orbit, that is the LEO satellites were being used. So these are not any new paradigms, but rather modern incarnations of the previous generation technology. So those are there. Then the massive MIMO technology with 256 antennas at the base station was already there in the 5G technology, but now we are evolving it and we are making it ultra massive MIMO. That is, we are trying to increase the transmit antennas from 256 to around double, that is around the range of 400 to 500 antennas, so that we can have higher data rates for using by the customers or the end users basically. But along with that, what are the computational technologies that are coming into the picture? So two technologies, if you see on the diagonally opposite sides, two technologies pave the way. One is the AIML based technology, which would lead to the high resolution architectures, or which would lead to the high resolution decisions, where you need to make decisions not in binary, that is zeros and ones, but rather you need to make decisions in gray. At that time, you, for the gray level decisioning, you cannot use regular conventional algorithm or evolutionary algorithms even. You should use the AIML based algorithms, the recursive algorithms, or the supervised algorithms, or the unsupervised algorithms, whatever it may be. But you need to use AIML based algorithm. But at the same time, for 6G enabling, another important aspect is the quantum communication, or rather I should say the evolution of the quantum computers, because it is not sufficient to use a AIML algorithm alone if your hardware is a normal hardware which works on the binary decisioning, that is 0 and 1. Rather, we should have the quantum communication as in the picture. Quantum communication basically means that the hardware will not be combinations of zeros and ones, but, or 0 and 1 hard and fast, but it will be a superposition of zeros and ones. That is, between 0 and 1 there will be different layers, or there will be different gray shades that we can decision. So the AIML algorithm will lead to such gray shade algorithms, and those algorithms will be realized in hardware by using the quantum technology. So all of you can understand from here that both the technologies cannot go alone. Each has to go hand in hand with the other basically. So that is the thing. And if I speak about a AIML technology, that what is the AIML enabled network, then all the possible applications that you can think of that were included in the previous generation of communications, including say the mobile management, how the at what speed the packets will move across the network, then fault management techniques, then your radio resource management techniques, that is how you are managing your spectrum, then then your routing technique and all other relevant techniques, actually all those things, then intrusion detection, the optimization of energy or power of your nodes, the sensor nodes, all those technologies are there, just that we are making those algorithms more smarter by using the AIML based technology. And if I speak about the physical layer based communications, the physical radio resource, then some of the very major challenges like the channel estimation based concepts or the modulation recognition concept. Channel estimation is one of the toughest challenges in the physical layer communications, and also nowadays it is not, we cannot say, since there are many computer science enthusiasts here mostly. So physical layer channel estimations are not only a physical layer or a ECE problem nowadays, it is a ECE come computer science problem, because we are talking about the mixed layer processing, that is we are combining the physical layer with the data layer for the channel estimation, and such systems or such models have to use the AIML algorithm. Similarly, the modulation recognition, that is what type of data or what type of data format you are using. There can be many modern data formats in your contemporary network. So the system has to recognize what type of modulation is there, and accordingly it has to adapt. The system has to basically recognize the modulation, and accordingly it has to adapt its receiver or its transmitter. So that part is also carried out using AIML. So in a AIML enabled network, all these possible architecture, all these possible applications can be covered. Now, just to have an idea about how AIML is actually affecting the technology, or how AIML is actually affecting our modern contemporary system, how it is being developed, how the technology is getting developed, Qualcomm and Nokia Bell Labs, they have actually signed one MOU. Or they are working collaboratively on a AIML based communications project. So I have a video from their labs, so you can watch this. It will be very interesting for you.
Excuse me, sir.
Yes, ma'am.
Sorry for the interruption, sir. I request all the participants to turn on the camera.
Yeah.
I
Madam, can I
request all
continue?
the participants to turn on the camera.
Ma'am, can I continue?
Yes, sir. Thank you, sir.
Okay, thank you. So this is the video of Qualcomm and Nokia Bell Labs that I will be playing for you. So I hope it will be interesting for you. Here we will see how AIML is used to generate the modern day AIML encoder and the modern day AIML decoder. It will be directly explained by the experts from Qualcomm and Nokia Bell Labs.
ഫോട്ടോ എടുക്കുമല്ലോ എടുക്കാൻ
Nokia Bell Labs are working together to unlock the full potential of wireless AI, creating a wireless system that learns and improves over time across different devices, networks, and technologies. By combining the power of AI with wireless systems, we're opening the door to a new era of smarter connectivity. To understand how AI can improve our experience, let's examine how it impacts one of the most essential tools in optimizing wireless systems: channel state feedback.
So this is very important. Channel state feedback.
helps
How
the
you
network
understand
figure
how
out
the
best
channel
way
is
to send
behaving.
data to your device. As
So
wireless
normally we use a
conditions
downlink
change, so does the
response.
optimal direction a transmission takes from the network to the device. Channel state feedback, however,
So from the base
allows the
station,
network to find those ideal avenues by
basically
generating
a
precise
beamform data is
Using
transmitted to
AI,
the mobile
we can
phone.
dramatically improve how the system
And these
tracks
pulses
channel
that
state
are going,
feedback,
these are the
making the
directed
network
pulses
and
to the
devices
intended
smarter
user.
and more efficient. Implementing AI effectively into wireless communications, however, is a complex matter. In even the simplest wireless system, There's a
So this is
network
the
and a
architecture
device
where
that
the
both
mobile phone
utilize
has
their
to
own AI
interact with the
models.
base
Those
station
models
and
need to
vice
cooperate.
versa, so
That's
that
the
both
heart
are
of
doing a
Qualcomm and
cooperative
Nokia's
communication.
joint research, getting AI in the network and devices to work together to amplify their benefits. To test their
This is their
AI-powered
lab
solution,
basically, the
Qualcomm and
Nokia Bell
Nokia Bell
Labs.
Labs set up a 5G test network
This is the
using
test network
cutting-edge
or the
equipment
antenna
and
slots
mobile
they have developed.
devices powered by Qualcomm 5G modem RF.
These are the
So it
persons
begins with AI
involved.
models, which are trained with shared
Carl
data.
Snoozman is a very
It uses
popular
a technique
scientist
called
from Nokia
sequential
Bell
learning,
Labs.
where the model and the network
So
device
here
is
you can
trained
see there is
first,
a model
and then the
communication going
model
on, and using this
both
structure, they are constantly moving
uses
to
shared
train the
data
system.
set
There is
to
a
make sure
network
that they
encoder
speak the
here,
same
there is a
language as
network
their
decoder
friends
here,
without
and
requiring
these are AIML
them
based.
to share detailed information about their implementation. After the AI models are trained and put them into action, the network device sends pilot signals down to the mobile device.
So from the network device, pilot signals or testing signals are sent to the mobile device, and you can see a AI encoder fitted inside. So the channel response that we are getting is AI enabled channel response.
Code that feedback and then use it to determine optimal beam patterns to focus the signal energy right to that particular.
We've been very pleased with the results so far.
We will also
Our
see
tests,
how it
we found
is
cyber training
when
has
it is at the
substantially
outdoor,
improved
how the outdoor referencing is done
compared to
basically.
traditional
Outdoor
models.
channel estimation, how it is
This
done.
shows just how much AI can enhance the performance of wireless networks. Since the collaboration
This
between
is about the
Qualcomm and Bell
outdoor.
Lab, we have
This you can
expanded
see,
our
that is
scope
the
in terms of
self-driving car of
research
the
and
Google. It
testing.
is basically being
We
used here.
have bring our models to
Internal
more
in
tested
indoor
areas
communication, this
compared
type
to
of
last
structure
year.
is being moved, and on the
So this
outdoor
year,
they are
our
moving the
primary
car
goals will
basically
be ensuring not
to
just the
get the training
interoperability
data.
but
All
also
the
the
data is constantly stored.
scalability of the AI models. We want to make sure it can work in different environments. We compare the performance of model which is
They have
trained
done the
with
necessary
data.
performance sorry, sorry, I could.
Clients are in the end, we're developing. So this means
I just replayed it.
AI models don't need to be trained for every specific site, which makes it much easier to deploy and use.
So as he is mentioning, we don't need to train the AIML model for all situations. Training it for 50% of the situations, it can work for the other 50% of the situations basically.
It's simple, powerful, and highly scalable.
As we continue our journey toward building smarter, AI native wireless systems, these innovations will pave the way for the next generation of wireless technology. Stay tuned for more as we continue to push the boundaries.
So I hope all of you liked the video. So this is about basically the Qualcomm and Nokia Bell Labs venture to develop AIML based wireless communication systems. Now coming to the next phase of the discussion, what are the common AIML terminologies that you need to relate when you are dealing with AIML in next generation wireless communications? Well, actually, if we think very clearly or very simply, then it is not that AIML with wireless communications is something very different or it's a rocket science. No, the same concepts as conventional AIML applications apply here as well. So basically, we will first have some data, and all of us know that in communications, already we know at the receiver that what kind of data we are expected to receive, whether it is a BPSK based data or whether it is a QAM based data, what type of modulation format the system is using, it is already known. So that way, the data is a labeled data. It is not a unlabeled data, or I should say it is a supervised learning and it is not a unsupervised sort of a learning. So this is the pre-labeled synthesized data, the pre-labeled synthesized data that we are using. Now that pre-labeled synthesized data is moving to the transpond. Moving to the transpond essentially means that it is that pre-labeled synthesized data is converted to some particular domain representation. It may be some frequency domain representation, it may be some spectral domain representation, it may be some discrete cosine domain, wavelet domain representation, anything. Now from there it will move to the train network that will train the epochs, and it will make sure that the necessary data that is required for the offline testing is properly trained. And we are training basically a model which can be either your convolutional neural network, the deep neural network, and any other AIML based network that we are training. And mind it, this trained model will now go to the actual stage, that is basically the testing stage. The trained model moves to the pre-trained model basically, which is written here. So what will happen in the testing phase? It is very simple. We will have the new signal, that is we will have the original signal. Since the training was done with transform data, so we'll have to transform the new signal also to the same status. Then the pre-trained model will act as the receiver. So essentially this trained model we are directly putting as the receiver. No statistics is being used, no mathematical computation. Directly the AIML based dataset trained model is directly fed in as the receiver. So we are essentially, if we think, we are simplifying the communication process, or we are simplifying the signal processing involved. And from that pre-trained model, whatever is your task, if it is about channel estimation, it will do the necessary channel estimation. If the task is a modulation recognition, that it needs to classify that a certain type of modulation is recognized and it is not belonging to the other types of modulation, it will do that particular situation. So, or it will do that particular application. So these are actually some of the AIML based approaches, or the AIML structure, or the AIML based structure basically, which operates in the next generation wireless communication. So these are the terminologies that are very common and you need to know if you are interested towards next gen wireless. So AIML target areas, there can be different target areas actually in the AIML based wireless communication. So those target areas basically are the physical layer, MAC layer, all the different layers of communication. All the layers have their necessary application. In these slides, in the coming slides, I will be speaking about two tasks in the physical layer. One is the channel estimation and the other is the modulation basically, or the modulation identification. So these are very core physical layer applications. Then in MAC layer, network layer, transport layer also, we have a number of activities which are actually a part of our network applications from long, like the mobility management, then your routing of the traffic, caching of the computational load. All these are activities that are going on, but we are using AIML based algorithms here to improve the performance of the existing layers basically, and it even goes up to high end applications such as the application layer. If I consider channel estimation as a problem, channel estimation means that the physical channel that our data is transmitting through, that physical channel is actually not known to us. If we understand properly, the physical channel is never properly known to us. So since the physical channel is not known to us, we need to estimate the channel so that we can neglect or we can omit the effect of the channel that we will get in the received signal. So that estimation itself can be that estimation of the signal can be categorized into different types. That can be based on the supervision, whether it is supervised, unsupervised, reinforcement based. Supervised basically means that the data will the input levels are also known and the output levels are also known. Unsupervised basically means that we don't have any information related to the input and output levels, and reinforcement is the most modern day implementation, which is a combination of both the aspects. So now again, the training strategy is basically the online or the offline, whether you are carrying out the training during the real time execution of the system or you are doing it on an offline basis. System implementation basically means that the channel characterizations that we are having can be either frequency selective, they can be block faded, or they can be step faded. So if that are there, then depending upon the different types of channel, the system implementation can vary. And also the training process, from computer science engineering perspective, the training process based classification can also be there, whether you are developing a system which is data driven in nature, or whether you are developing a system which is model driven in nature. That is, whether you are training the system only based on the data or you are training it for different types of model. What does it mean? We'll see it. So you can see here there is a structure of the channel estimation where I am basically referring to a OFDM based channel estimation process of the previous generation. So you can see here very clearly that when we are talking about this, then the transmitter and the receiver that are here, those transmitter and the receiver hardly change as compared to the previous generation, that is the 5G technology. Rather, in only in the offline training, since we are doing channel estimation, so the different types of symbols and the different possible channel models, they are fitted as simulation data to the DNN, that is the deep neural network. And only in the receiver, all the other blocks will remain the same. Only the data recovery block, where you will actually decide that whether you are decoding the data as a 0 or whether you are decoding the data as a 1, only that recovery part will basically be affected. So what we can understand is that only this DNN architecture that is there, that will go inside the recovery data block, and only that single block will be affected, so that that channel estimation process can be called as a AIML or deep learning based channel estimation. This is as per the code from the electronics letters published in 2023. Similarly, if you are doing the same thing for modulation,
Excuse me, sir.
then
Excuse,
yes, sir. Yes,
excuse,
yes,
sir.
yes.
You are talking about this thing. You are going to explain any algorithms we are using, like what particular algorithm is suitable with more accuracy or precision recall. Which one
Yes,
justifiable,
yes,
sir?
yes, yes. I will be enlightening on that in the next few slides. Is it okay, sir?
Okay,
During the
okay,
coming slides, because I am just giving a task or a kind of what are the application areas and the brief thrust about the block diagram. Next, I will also show my work that I have done in the similar manner, and there I will show the algorithms that are published algorithms. Actually, is it okay? Is
okay,
it okay, sir?
okay, sir.
Yeah.
Thank you, sir. Thank you, sir.
So that way, actually, so now the other technique is basically the modulation detection based algorithm, the AIML aided modulation detection. So the for modulation detection, as I have told you, the different data formats or the different modulation formats that are there, those will be basically again detected through the AIML training, which will be done in an offline stage basically. And that offline stage here in the previous one, since it was about channel, so I trained the data with the symbols and the channel models. But here the training was done with the transmit symbols. Again, the symbols are there, but the modulation type, the different types of formats that can be used to modulate the data. And after combining them, we are fitting a DNN based network here. And this particular DNN based network that I am pointing with my cursor, that will move into the modulation recognition network. That is basically the modulation recognition network that is there, and from there it is the detection network that is there. So these two work in the synchronization. The modulation recognition network will recognize based on this DNN training that what type of modulation has come in the receiver side. And once this particular modulation recognition is classified, once this modulation recognition classifies which type of network, the detection network will get triggered. And suppose it is saying that you have XYZ type of modulation technique, suppose QAM type of modulation technique or AES type of encryption or modulation technique, then the detection network will become a receiver of the AES, or it will become a receiver of the QAM, or it will become a receiver of the QPSK. So it will adaptively change as per the information or the trigger of the modulation network. But if I say except that block, what are the changes in the other blocks of the communication? It is nothing. It is just about simplifying the complicated task. So these tasks were earlier done using the statistical methods. Now these are done using the AIML or dataset based methods. That is basically at the core, that is the difference about the modulation detection. That is basically the kind of difference that we have in our system. It is very simple. We should not think that it is becoming that the structure is being massively changed. Similarly, the AI-based, AIML-based beamforming and the beam management systems are also a part of the are also basically a part of this particular thing. So beam forming basically means that if there is a particular person that is standing here, then the beam that is coming from that particular antenna based structure, actually that beam should directly come to that in the desired angle. If the person is standing with reference to this beam at 48 degree, 48.3 degree, then the signal should not come at 48.2 degree, rather it should come at 48.3 degree only. So if it is the ground wave propagation, it is azimuthal beamforming, and if it is a height based or a altitude based beamforming, it is the elevated beamforming. In both cases, to tune the waves or to tune the energies in the best possible way, we are using algorithms. The most popular algorithm for the beamforming till 5G was the SWIFT algorithm, SWIFT, SWIFT algorithm. But with sixth generation coming into the picture, now we are trying to use AIML integrated with the SWIFT technology. And in such AIML based technology, the CNN based architectures are used to support the SWIFT technology. So this is the beam forming on the left, and the right side is basically a beam management. As you can see, there is a car that is moving and is being served by this particular roadside base station, whereas this bigger truck is being supported by this blue wave base station. So blue wave base station. As you can understand that the car is also moving and the truck is also moving. So after some time, there should needs to be a automatic shift in the beam. That is, the truck will be supported by the beam that was supporting the car earlier, and the car will be supported by the beam that was supporting the truck earlier. So for that, what is to be done? This frame has to be constantly fitted to a DNN based architecture. And here specifically we are using DNN and unsupervised learning of the image pixels. So here this entire structure of the DNN will have a number of input, hidden, activation and dropout layers, and this will constantly track the frames that are coming in, and based on that frame it will ensure that whenever the car shifts to a position of the truck or the truck shifts to a position of the car, the moment the base station has to change, at the same time only the beam will get changed, so that the beam is managed very properly. So for managing the beam as well as for forming the beam, that is to ensure the power and also to ensure the management, in both the aspects we are using basically the beam forming or the beam management process. We are using the AIML based technology. Minded, beam forming is a completely physical layer based communication aspect, mostly concerned to the ECE engineers or ECE researchers, whereas the beam management process is a purely communications problem, which would interest more of the 6G, which would interest more of the computer science background researchers. Another important aspect that had died out towards the entire fourth, or rather I should say the fifth generation of communication. Still the last part of fourth generation it was there. That is the cyber security aspect, and specifically the cyber security based aspects of the 4G communications. That was basically a major challenge actually in the context of 5G, because already people were mentioning that once the beamforming based structures that I have just explained are coming into the picture, we are anyways able to give directed beams and no eavesdropper. So as all of you know, in a cyber security scenario, the trusted transmitter is a Alice and the trusted receiver is the Bob, and any person who is unauthorized and wanting to get access is basically known as the Eve or the eavesdropper. So no Eve, with beamforming in place, it was assumed that no Eve can ever track the Alice and Bob information at the physical layer level. But what proved us wrong was basically the Russia-Ukraine war, which came into the picture, where the one of the countries, without going into the details, one of the countries they actually tried to hack the internal or the inter-communication satellites or the inter-satellite communication between the two satellites of the nation. And what was found that because of the breach in the physical security, not the network layer security, but because of the breach in the physical layer level security, there was a lot of issue in keeping the data secret, and they could easily wiretap the channel and the communication got disrupted. So this led to new research, and now most of the Western countries are going into very effective and channel authorized research on these type of areas. So the AIML based physical layer cyber security, where we can have a secret message of M bits which is encoded for Alice and it is passed to the decoder of Bob. So only Alice's encoder and Bob's decoder will be synchronized, because it will be trained through the same neural network or the similar type of neural network, which is basically a DNN architecture, and both will be synchronized in nature. So even and these weights of the different layers or the activation functions will basically not be not it will not be in the updatable status. Basically it will get constantly updated. So even if the Eve is able to decode a complete structure of the DNA also, still the updating of the functions cannot be performed by Eve, and thereby it will never be able to wiretap the information that Alice is sending to Bob, which in the earlier case it could, because we are not using AIML based encoder and decoder, rather we are using the statistical based encoder and decoder. So these are basically the structures, the modern day structures. The first left work was by Tefera, which was published in the Sensors Journal 2022, whereas the other work was of the Intercopen Journal in the 6G physical layer. But here we should mind that we are talking about cyber security at the physical layer level, or yes, or radio resource level, and not at the not at the higher layer level basically. So now we have something which is of very prime importance, which has been published by the articles of Qualcomm in two aspects. One is for AI, the other is for ML. So this is basically the fight or the tussle that is there between the old generation researchers and the new generation researchers. That is actually the we tend to think that once we are implementing the 5G sort of scenario, or the say 6G sort of scenario with AIML based technology, the receiver's essence, or the impact that statistical references or statistical models had on the communication based systems, whether it is physical layer communication or the higher layer level algorithms, that would go away. No, it won't, because actually AIML is fitting in to solve the problems that wireless or statistical channels could not. Suppose with wireless there was an issue related to modeling of the problems. We could not model every channel state problem or every network level channel state problem also using the statistical means. Whereas AI actually it can be very easily used to give you beautiful representations of hard to model problems. Again, computational feasibility is another issue. Computational feasibility basically means that you cannot have a 60th order based polynomial regression algorithm, but when you can't have it, better go for a near ideal solution which is computationally realizable using the AIML based structure. And the other aspect which is very important is the dealing with the non-linearity. Basically, the non-linearity functions we are dealing with, and that non-linearity function when we are dealing with, we are having the modeling of the non-linear function. So non-linear, we are trying to model every wireless problem or any networking problem always as a linear model in our computation or in our mathematical framework, because we are finding it difficult to handle non-linearity with basic statistics. But AIML is specialized to handle non-linear functions. So this is a very important tool. So as you can understand, AIML is only aiding or supporting the statistical model, and it is not taking away the importance that statistical models will always have in the wireless communication scenario. An example of this work can be two examples of this work rather can be seen in this particular model. So basically this is a structure where you can see the training of the data for a channel measurement or channel estimation is going on through the DNN, and here you are having a statistical model parameter. So this DNN model is actually just aiding this statistical model, and this statistical model, as you can see on the right hand side, it is a Markov model. This structure, all of you know, it is a statistical or a semi-statistical Markov model, which is basically the state diagram for all possible state transition, and the matrix corresponding to the model is actually nothing but a model for the MIMO channel or the multiple antenna or the multiple input multiple output system. So this particular model is getting fitted here, and ultimately you can see it is getting activated through the trigger from the DNN network. So this type of structure is basically published in the wireless personal communications, and it directly shows that AIML is integrated with Markov model or statistical model for the next generation wireless communication. Another work that now I want to represent for the particular respected sir or the gentleman who asked regarding the particular work. So this is another work or an algorithm that I had developed where I was integrating. This is a paper published in the IEEE Access Q1 journal of mine. So this is basically the integrated stochastic and AIML based design, where what I was doing was I was developing a short range communication link, obviously a physical layer short range communication link. So that link was having both NLOS as well as the line of sight paths, and we could develop it for a short range user also and later on expand it for a long range user also. So as you can understand here, this structure is a core wireless communication structure where there are all the possible communication block diagrams or all the possible communication blocks that are there. Only this part, as you can see, is the channel modeling part, which we focused on in our research. Where firstly we had the baseband based MIMO channel, and after that, we, since it is a short range communication, the effect of correlation in antennas, that is when two antennas are placed close to each other, one antenna signaling affects the other antenna's signaling. So in that, actually the Kronecker correlated model, it comes in very handy for us. The Kronecker correlated model, it comes in very handy to analyze what is the effect of the correlation of the antennas basically. So that is that work we were focusing on, and after that we tried to go for the equicorrelated millimeter wave model, the system diagram basically, how this correlations which affect the performance of the system could be affected. So that particular implementation or the algorithm we could develop firstly from the basic millimeter wave channel modeling. We used a AIML based approach, which was a CNN based approach, to develop the Kronecker based model, which was earlier developed by many statistical modeling also, but we have developed the same model using the Kronecker AIML based model, which is a CNN model I am again mentioning. And later after that, we are using a DNN based structure to equicorrelate or to make sure that the correlations are the minima, so that the performance of the system is the maximum, or the capacity performance of the system is the maximum. So that type of analysis we have done in this particular model. So I will again come to this work with some results. So now this you can see is another work by Silva, which was published in Journal of Wireless Communication and Network. So in this particular Journal of Wireless Communication and Network, we are having the WaveDM symbols basically, the WaveDM symbols, and it is a total block which comprises of all the WaveDM architecture that is there in any conventional 5G system. But here they are using to differentiate between the symbols or to
என் கிளாஸ்ல
categorize
இருக்கிற
the symbols. They
பசங்களுக்கு
are using the PCA based
நான் வந்து
implementation.
மோட்டிவேட்
All of
பண்ணி
you
அவனை
researchers will know
கம்பெனியில் வந்து
that
பிளேஸ்
PCA
பண்ண
is the
வச்சு
principal component analysis.
என்
So principal
பிளேஸ்மெண்ட்டுக்காக
component analysis is supposed to be a totally statistical approach towards the categorization problem or the classification problem. But this PCA based analysis, here they were implementing not statistics but rather a 4-layer architecture, a 4-layer DNN architecture. Again, for the person who has asked this thing, that what type of specific algorithm, that these are the specific 4-layer DNN architecture that they are implementing in the PCA based system basically, in the principal component analysis. And the principal components that are there, instead of using the statistics, we are using the 4-layer DNN architecture here, or 4-layer DNN algorithm to get access to the principal components of the system, and that particular principal components are fitted in this particular block. So essentially, always in any problem, only 1 or 2 blocks will at max get affected, and rest of the blocks of the problem will always remain to be the same, like the non-AIML approach. So that is the thing. This was the paper that I had just left off earlier. This was the Q1 IEEE Access paper that was published. So you can see here that I am developing the channel model basically as per Robert Heath. Here I have cited Robert Heath also as per his dictionary based channel approach, and I am able to see here in equation 2 that the channel matrix or the physical radio resource has a dependency on the A, B, C, and D. That is basically your total architecture, the total A, B, C, and D. That is basically the channel matrices or the channel parameters, and they are dependent upon the steering vectors along with the conventional tabs. That is H11, H22, H11, H22. This type of parameters, they are also associated with AT theta T, that is basically the transmit steering vector and the transmit receive vector, and also the AOA and AOD are getting connected here. So these are basically the dependencies. So what we could understand, by tuning the parameter, by tuning these angles of arrival and angles of departure, we can affect the channel, and thereby we can affect the performance of the system. And that led to the conclusion that when we were deducing expressions or closed for expressions for our system, that is basically the bit error rate, or rather the symbol error rate, then we were having dependencies on big omega and big sigma. Big omega is the transmitter correlation matrix, and big omega is basically the receiver correlation matrix. So the system actually depended upon omega and sigma. So by varying the correlation, by tuning these angles, we can vary the correlations, and thereby we can vary the performance both for the average SCR and also for the high SNR SCR. Now, if that is the case, now in here as well, if you see that the entire ABCD parameters, this rho, that is the correlation coefficient, Pearson, which is commonly known in computer science as the Pearson correlation coefficient, that is basically the estimation function of all these parameters. So based on that, we can vary the rho to vary the entries of these matrices, and that can be done in practical level by tuning the hardware or tuning the angle using the intelligent antenna hardware that is available in 5G. And by doing that, we can tune the matrices, that is transmitter and receiver correlation, and we can receive the necessary performance. So you can see here we have plotted it using the MATLAB and Python mixed environment, and we can see that for the low correlation model that we developed, the SCR performances are the best. We could also do the same thing over the different antenna configurations. We could get the same results over the different modulation schemes down here, and also we could have a very important result due to which the publication was granted, that is that from in a very low power scenario, very remote application like say minus 10 dB to minus 20 dB, the same system also sustained in that particular range. So if we are having sustainability in that particular range, then obviously this system will be very useful for low power applications also, and it is very important conclusion. Similar in this case also, another graph which shows the same results, and if we compared it the system with different AIML based algorithms which were strictly focusing on AIML based, whereas my system is focusing on AIML as well as the statistical based approach, basically a AIML aided statistical approach. So that was giving a much better performance as compared to the approaches which use only the AIML. So always as researchers we should understand that whenever we are going for the AIML based approach, we should not always try to eliminate the statistical blocks or the statistical branches that are there already created in the system, but rather we should just try to add AIML as a supporting element, and this publication itself proves basically. So at this point we are we are stopping off with the AIML based part, and at the next juncture, for the next few minutes that are left over, I shall be speaking up on the quantum based approaches, briefly on the quantum based technology, that is how quantum is affecting also in the parallel way. So I want to just show one video over here, a very short video, to imagine how actually the world would look like by 2030. So I would play this video, and after that we can have an interaction for 1 or 2 minutes if any faculty is having any particular doubt till this point. I will just play the video for a couple of minutes.
Imagine a world where your device is not just connected, but intelligently anticipates your needs. Welcome to the future, 6G and AI. As we stand on the brink of a technological revolution, 6G promises to transform how we interact with the world around us. But how do we harness its full potential? Thanks to artificial intelligence. With 6G, we encounter challenges like unprecedented data volumes and the need for ultra reliable connectivity. AI steps in as the game changer, offering solutions that redefine communication. Imagine AI-driven networks that optimize themselves in real time, ensuring seamless connectivity even in densely populated areas. Or picture AI algorithms that enhance data transmission efficiency, making delays a thing of the past. Let's delve into practical applications. In smart cities, AI and 6G could manage traffic flows autonomously, reducing congestion and improving safety. For healthcare, think of AI powered remote surgeries with real time feedback, breaking geographical barriers left there. AI also plays a pivotal role in environmental monitoring. By analyzing vast data sets collected through 6G networks, AI can provide insights into climate change patterns, aiding global conservation efforts. As we explore these possibilities, it's clear that AI isn't just an add on for 6G, it's an essential pillar that supports its structure. Together, they form a synergistic duo, driving innovation and unlocking new horizons. In conclusion, the integration of AI and 6G isn't just about faster speeds or better connectivity. It's about creating a smarter, more responsive world. As we prepare for this next leap in wireless technology, possibilities are truly endless, and the future is within our reach. Stay tuned as AI and 6G reshape the world as we know it. Connect with me for more insights on AI and 6G. Imagine a world.
Okay, so with this we can understand that AIML is paving the path for a new generation of wireless communications and networking. So at this point, are there any questions that I would love to answer for a couple of minutes, and then we can move to the next part of the lecture that I will be speaking about, that is the quantum based communication for a short while. So at this point, any participant is having any query? Am I audible? At this point, till
This
the
point till the
current part that we have discussed,
we have
if there is
discussed,
any
there
query,
is any query.
Dr. Kartika, I am audible, right?
Yes, sir, you're audible.
Yeah. So
So
any
any
queries that
any
any of
queries
the
that any of
participants,
the
then we can answer,
then we
and
can
then we can
answer,
move
and
on
then
to
I
the
can
next part of the lecture that I will be speaking
that
of
I'll
for
be
next
speaking of
15
for
minutes.
next
Any one of the
any one of
participants?
the participants.
ஆடிபிள்னு கேட்டான் அதான் ஆடிபிள்னு ஒரு அம்மா சொல்லிடுச்சு
Sir, good evening,
நீ
sir.
பொறுமையா
Very informative information about
Yes, sir.
networks to 1G to 6G
Yes, sir. Yes,
and
sir.
AL, machine learning and AI.
Yes, sir. Yes, sir. Thank you, sir.
My question, the basic question is
Uh,
that every person to know about technology and
yes, sir.
every person like one year this year to purchase a one phone to use
Uh,
to 3G mobile. Yes, sir.
yes, sir. Yes, sir. Yes, sir.
Sometime after he purchase technology change to
Uh,
4G mobile,
yes, sir. Yes, yes.
and
Yes, sir.
sometime after technology change 5G mobile.
Yes, yes. Yes, yes. Yes,
Sir,
sir. Yes.
sir, the person use this type technology. So
Uh,
these the garbage is the very store to the market, and some company is to our profit now to profit purchasing to every time purchase to new technology, but
yes.
consumer just lost the money.
Yes, 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 sir. Yes, sir. I would like to address that. Actually, very important question that Sir has pointed out. Actually, sir, the thing is that one vertical of 6G is also that. Actually, what happened? We had a very brisk growth or a very speedy growth in the technology from 1980s till 2020s, from 1G to 5G, as you saw. And that what happened, the technology was changing very abruptly in each of the generations. From one generation in 2G we were having texting, in the 3G we were speaking about the internet access. Basically the total mobile internet came in 3G. In 4G we were talking about long term evolution technology. Actually, so it were massive growths in technology. So that is why that problem was happening, that once a person purchases one generation phone, suppose the 3G phone, once 4G comes in, he has to completely change that handset. Obviously, up to some extent it is also a market strategy, or it is up to some extent it is also about the mobile phone sellers. But the technologies actually help them to do that sustaining business, and all, because the technology growths were very immense. But when I am speaking of today, that is, we have already achieved the necessary technology parameters, the standard parameters of with the fifth generation of technologies. 6G now, sir, will be all generic. 6G onwards, everything will be generic. You need to expand. Suppose if we consider the 5G data packs also, it is not a mandate that with the 5G phones you have to use a 5G data pack only. You can run with 4G wherever 5G is there, it will automatically shift to the 5G speed, and wherever it is not there, it will support the 4G. Similarly, 6G, when it comes in the different generations of the technology, the higher generations, then always it will be backward compatible, that it will not be anything new, but rather it will have a backward compatibleness, that in a 6G phone the entire 5G architecture will be there, or in that 5G phone that you are using, the entire 6G enabling facility will be there. It is not that you have to keep on changing your handsets or keep on changing your data packs, and that will not, firstly, it will not lead to the unnecessary purchasing of phones just as the generation changes, and secondly, the wastage that you are talking about, that is the garbaging part, that is the carbon waste or the e-waste, which is a major problem of not only India but all the countries. So that will also be reduced when across say 3 to 4 generations of technology you don't have to change the headsets. Maybe after every 4 or 5 changes in technology trends, say 7G, 8G, 9G, you have to again change the handset, but not from 4G to 5G or 5G to 6G. I hope I have answered the question query, sir.
Yeah. Thank you, sir. My second part is,
Yeah.
sir.
Sir, can we do one thing? So we have another part of the, yeah, another part of the lecture. So I will just go through it, and after that maybe we can have detailed interaction. Is it okay, sir?
Thank you, thank you, thank you.
Definitely would like to interact, madam.
Okay.
Dr. Kartika, I think we have interaction, so I think I can move with the next part. Is it okay, ma'am?
Yes, yes.
Okay. Okay, so now after we have discussed about the after we have discussed basically about the AIML based approaches to the technology, we should also understand, as I have mentioned, AIML will only give us the basic understanding of or basic realizations on the software level or at the programming level, that how well we can take the decisions, how well in gray status we can take the decisions. That is, the decisions that we are mapping, we should mind it that every hardware at the end of the day, whatever complex algorithm we are implementing, it is, we are in the digital age and our computers are digital, and it is ultimately mapping everything to a 0 or a 1. That is the major concern. So whatever complex architecture that we are implementing, or complex algorithm that we are implementing, ultimately it is all about a 0 or a 1 at the end. The decision is all about a 0 or a 1. The resolution may vary. That is all. But the question is, if we are taking such gray levels of decision, where is the hardware to support that gray levels of decision? So for that, wireless communications will not only work in the next generation with AIML, but rather it will work in the next generation with the quantum computing based approaches. So the quantum computing approach basically means that, as opposed to a classical state of our structure, which is either a 0 which is represented by a black dot or a 1 which is represented by a colored dot, we have quantum states. Basically, we have quantum spheres where these different dots, they represent superpositions of zeros and ones. That is, the bits are not strictly 0 or strictly 1, but they are 0 approaching to 1 with some percentage, or they are 1 approaching to 0 with some percentage. And if we understand, it is, say, 0 with a probability of 15% or 1 with a probability of 85%. And where from does this concept come? So these bits, when we get 15%, 85% sort of distribution of the bits, and not fixed bits as 0 and 1, these are no longer called bits, but rather they are known as the quantum bits, or they are known as the qubits basically. And that comes from the concept of the atomic theory and Heisenberg's uncertainty principle, which says that any electron in nature has partially the particle nature and partially the wave nature, which is true for every living being in our system. So basically, that is the basics of the quantum computing. And once we have decisions which are focused towards not only 0 or not only 1, but rather it is some percentage 0 and some percentage 1, then what will happen? It will be a superposition. We will have multiple decision states to choose from. So that is the power of quantum computing. That is, not only the software will be a gray level software which will take very very accurate or gray type of decisions, but the hardware will also be a gray sort of a hardware where there will be multiple decisions between 0 and 1. So that particular thing, so there was a video here. I would just like to focus on I would just like to skip this video in interest of time. I would like to make you understand what is or how quantum computing is coming into the picture with another video. Actually, I will come back to these two slides. So you can just watch this video where this person actually is very clearly explaining what we understand by quantum computing. So I request all the participants to please watch this video. You will find it very interesting.
Quantum computers. There's a lot of stuff out on the internet and on YouTube explaining quantum computers, but frankly, they're all pretty advanced and pretty confusing. So I'm going to try and boil it down in an easy to understand way. Okay, so we all know that normal computers uses bits, zeros and ones for data and processing. So for example, if I have 4 bits in a row, I can represent a bunch of numbers. For example, 0000, 0001, 0010, and so forth. And I can keep on going. Now, quantum bits are also 0 or 1, but it can also be
Please
0
observe this
and
part
1
very
at the
carefully.
same time.
It is a 0 and a 1 at the same time. Very
Well,
important.
it's not. It's actually pretty easy to understand. For example, let's say that a bit is kind of like this coin. It can either be heads or tails, just like 0 or 1. It can only be either heads or tails, right? Wrong. Okay? If I were to toss this coin, you can see that while it's in the air, what is it right now? Is it heads?
What is
Tails.
the
Now, in a weird
format
way,
of the
it's
bit?
heads and
I'll
tails
just
at
pause it to state that word for you and again play it. What is the value of your bit when you are tossing the coin, whether it is a head or tail, whether when it is in the air? What is the state? So it is neither a 0 nor a 1, or you can say it is a 0 with some percentage and it is a 1 with some percentage. That is basically what is quantum bits.
the
So I'll just
same
play it.
time. It doesn't really even make sense. Now, in a weird way, it's heads
I'll
and
just repeat
tails
for
at
you.
the same time. It doesn't really even make sense until it collapses in my hand and I observe the coin and then I can see what it is. So that's the idea behind a quantum bit. It can be a 0 and a 1 at the same time. Okay, great, but what does this have to do with computers? Well, now is where the fun begins. Let's go back to those 4 bits. Let's say that I am trying to crack a password. The password I'm trying to crack is one of these numbers, but I don't know which one. So I've devised a machine to try them all. This is a normal computer. I take one number, I put it in my machine. If it's wrong, it gives me an X. But if it's right, if the password is right, then yay, I've got the right number. So a normal computer would try each and every one of these individually until it finds the right answer. Now, what if we use a quantum computer? So instead of putting in these 4 regular bits, we put in 4 quantum bits. Now remember, each bit is both a 0 and a 1. That means these quantum bits are all the numbers all at the same time. So when I put the quantum bits into my machine to find the right password, what comes out the other end? Well, it turns out the machine is saying that I'm both right and wrong because I gave it both right and wrong answers at the same time. I still want to
So
know
it can
what the
easily
correct
detect
password
very
is.
tough
Well,
codes
there's a
or hack very tough
called a
codes
Grover
because it is
operator.
0 and 1
This is
at the
actually
same
a
time.
real thing
And
where
the
you
Grover
can
operator
sweep
helps.
away
The
all
Grover
the wrong
operator is
answers, and
one
what
of the
you're
quantum
left behind
operators.
with is the right answer. Okay, so that's the beauty of quantum computing. Instead of trying each and every value like a normal computer would, a quantum computer tries them all at the same time.
At the same time, it compares all possible
encryption.
combinations.
Those would take a regular computer millions of years. In fact, I heard some people say the age of the universe to try and crack these codes. That's how secure they are. But with a quantum computer, you can try them all at the same time. use the Grover operator to sweep away all the wrong answers, and what you're left with is the right answer. So instead of taking millions of years with a regular computer, you can do it in seconds with a quantum computer. Now, what are some other things you can do with a quantum computer? Well, let's take something we're really familiar with. What about a point? Distances between 2 points. What Google Maps does, what regular maps do, is they look at all the different possible paths between 2 points. They try them one at a time and figure out which is the fastest one, which is the shortest distance, which is the optimal one. And that takes a long time. That takes a lot of computing. With a quantum computer, you could try every possible path between 2 points all at the same time and pick the best one. Okay, this is huge because the rise of self-driving cars is coming. And imagine having a master system, a master quantum computer managing the entire system.
So this kind of quantum computer structure will actually manage self-driving cars in the
to
future.
avoid hazards and avoid accidents and figuring out when the lights should turn green and red. And suddenly you have the best possible commute because it's literally tried everything in the universe and has found the one solution that is the best that works. Okay, that's a quantum computer. Regular computers could never do that. Okay, what about artificial intelligence? What if we gave a quantum computer the ability to reprogram
So this
itself?
structure, all of you please see. This structure is basically the hardware supported by the artificial intelligence program. So programming basically means wiring and rewiring. So if this frame is basically the quantum hardware and these hands or the robotic arms are basically nothing but the quantum or basically nothing but the AIML based algorithm mappers, then they will do this type of an operation. This operation that I will just
Okay, what about artificial
this one,
intelligence?
just
What if we
observe the
gave a
figure
quantum
once.
computer the ability to
This one,
reprogram
this
itself?
movement.
Well, computers don't
So this
really
is
know
what
the best way to
quantum
reprogram
computer
themselves.
means for artificial
Yeah,
intelligence.
a normal computer would have to do trial and error and see what works and what doesn't, what makes itself better and what doesn't. But
Okay.
a quantum computer can try every single possible program and find the best one. It could try every single possible circuit design and make itself the best. Okay, and that's kind of scary because in an instant, the quantum computer could figure out how to reprogram itself and remake itself into the best possible artificial intelligence ever. And if that doesn't blow your mind, I don't know what will. Okay, that was it. Hopefully.
Okay, so in interest of time, I will skip this video. It is the very lucid and easy way of understanding that how the AIML algorithms will use the flexible quantum hardware to reprogram and reprogram itself continuously so that they can give us n number of solutions or they can give us solution to any very complicated problem which would be not possible alone with AIML algorithms. So that is the necessity of the quantum architecture. So if I consider quantum AI, as of today, we are not having quantum hardware with us. So quantum data as of now is a state of 0 and 1. So how do we prepare how do you work with the quantum AI? Basically, you first prepare the quantum data, you do the data processing. By quantum data, I means the data which is mapped to qubits. That is not completely 0 and 1, but 0 with some probability and 1 with some probability. So that is the thing. Second is the data processing. Data processing, basically data processing means that you have to process or pre-filter that data that you have created. Then again, the unfortunate thing is, as of today, you have to convert it into the classical data and you have to go for the classical AI analysis. This would be removed or improved as soon as quantum hardware has become a reality in our state. Learning and improvement, always you can have learning models to improve upon the AI architecture. Then you can advance your model. And another aspect that you can use that is already there actually in the picture, neural networks with quantum bits or neural networks with quantum activation functions have already come into the picture. So instead of using regular DNN architectures, you can use DNN architectures supported by the quantum technology, that is the QNN. And that particular process that I have shown here in steps, that is represented by this type of a structure where any algorithm will be fed with a quantum channel. So all of you must note that if you are using not a regular computer or a CPU but a quantum CPU, the data has to be fed through a quantum channel, that is a optics based channel or a light intensity based channel, and from there through the quantum channel you can make the AIML model train and you can have a feedback mechanism here which will constantly update the weights so that the quantum AI or quantum ML system can perform well. And there can be different types of quantum AI architectures, including shallow intelligence, where we are using basically we are aiding our AI/ML systems through aiding the statistical systems using AI/ML mechanisms such as regression, classification, clustering. We can have deep intelligence, where we are talking about self-design and self-configuration. That is a hardware that you are developing will constantly keep on updating to make sure that the power that it is occupying or the power that it is exhausting, it is the minimum. So that those are self-design or self-organizing architectures. Then we have multi-domain intelligence, that is whether you are taking the knowledge level information, whether you are taking the analytics level information, whether you are taking the consumer level, whether you are taking the knowledge level information, or the whether you are taking knowledge level or say analysis level or the comprehension level. All of you are professors here, I believe mostly faculty members here. We are constantly working on the KCA, or we are talking about the Bloom's taxonomy. So in Bloom's taxonomy, we are having the different levels of intelligence. So that level of intelligent mapping actually can be done using quantum intelligence, where for your particular syllabus or for your particular file, actually the AI/ML algorithm will decide that what would be the best question paper that you can serve to the students so that their intelligence is improved in the best manner. So that those are the structures. And also today all of us are aware about abstract intelligence, because the concept of generative AI or generative machine learning has already come into the picture, where we are constantly using AI prompts to support our system basically. So this is quantum intelligence. So this is the different types of applications of quantum AI. So quantum, for those who are new to this domain of quantum, we should think of quantum AI/ML simply like any AI/ML categorization. That is, just like AI/ML is a subdomain of AI and deep learning is a subdomain of ML. Similarly, quantum AI is the superset, and quantum machine learning is its basically the subdomain. And inside that we have the quantum deep learning. And basically most of the quantum learning architectures are deep learning architectures, because we are talking about layers, or we are talking about sub layers basically. So these are so we are not saying here about architectures which are not deep learning based, rather all the architectures will be deep learning or CNN based architectures. So this is as published in the Quantum Global Group, which is a very famous journal in the quantum domain, or a very famous magazine in the quantum domain. Now, another important terminology that all of us need to know is basically the federated learning or the federated quantum machine learning. So, regular quantum machine learning, as you can see on the left, will have only one set of training testing phase, where we will have some quantum data set represented by v1 cap, v2 cap, v3 cap. These are basically input vectors, and they will be processed through some basis functions, u cap phi1, u cap phi2, u cap phi3, where we will evaluate the quantum model, and based on some averaging method, finally we will evaluate the DNN, or we will evaluate or train the DNN, or not train, rather we will test that DNN which we have trained in the background. So this structure which will do the total processing only once or only at one place, that is basically your quantum ML structure, or the quantum machine learning structure basically. This is the entire structure. Whereas if this particular structure is repeated locally on different quantum computers, suppose this u theta, this is one frame computation, this same frame is repeated layer by layer for different data sets or different quantum computers based on some initial parameter, then we will have different model parameter updates, that is theta t plus 1, theta t plus 2. That way there will be number of parameters that are compiled, and all those parameters will be fed to a global model. The global model will decide whether the system is totally optimized or not, and it will again feedback information to each of the layers, and that way the processing will continue until the global model is completely global model parameters are completely optimized. And all of us can understand that these layers basically means that this is decentralized processing. So whenever you are doing quantum machine learning process over decentralized layers or decentralized places, then it is federated quantum machine learning algorithm. Blockchain based problems, wireless communication, channel estimation problems in physical layer, and network parameter optimization problems, they are dealt with using federated Q machine learning algorithm. For the gentleman who asked regarding what type of specific algorithms we will be using in the modern day problems, where you have concept of network optimization, power and energy efficiency optimization, where you need to take into account the different nodes and the properties associated with the different nodes. We are trying to use federated quantum machine learning instead of the quantum machine learning. Or even if it is not quantum, if you are using normal machine learning also, there also we try to use the federated machine learning in place of quantum machine learning. So this is another aspect basically. What would be the role of AI/ML in the next gen 6G applications? If I try to say, it will be used in any of the applications, or all the applications in networking, or all the applications in communications that was there in the previous generation. Starting with the routing, that is which would be the best path so that the delay is the minimum. Content catching, how you will segregate the data so that you can process at the fastest. And task offloading, one of the most important algorithms which I will show in one work in one or two slides, that is basically the offloading. That if we are having a cellular structure with a base station, we are now trying to create small sub base stations nearby to each of the mobile users, so that those sub base stations can support the nearby devices, so that the load on the main base station that is having very high processing capabilities, that load could be reduced. And that operation is basically the task offloading operation. So that is the thing. Then these are some of the quantum IT applications that I have listed. So all of us should understand that the entire quantum operation operates on this term, that is QKD, that is basically the quantum key distribution. That is the secret key that is shared between the transmitter and the receiver through a classical channel, even before the communication actually starts. So it is a back-end code that we are sharing between the transmitter and the receiver, that is through the classical channel, and that particular code is basically the quantum key distribution. And after doing that, the transmission between Alice and Bob, that is the sender and the receiver, starts. And that application of the Alice and the Bob, it actually starts. And there we are using a quantum channel, not a classical RF channel, but we use a quantum channel, because we are not sending bits over the classical channel, rather we are sending light intensities. This upward arrow means it is a 90-degree, or it is a 90-degree light intensity. The line on the horizontal means it is a 0-degree light intensity. This means it is a 135-degree light intensity. This means it is a 45-degree light intensity. So light intensity. So instead of sending bits, we are sending the light intensity or the phase angles basically in the quantum communication. And quantum IT can be communication application. It can be purely computing applications, where we are dealing about optimization, resource allocation, then blockchain, etc. computing. It can be also sensing, where we are trying to synchronize the system. We are trying to localize or find out a particular user, or we are trying to, even in radar applications also, quantum is used heavily. So there is one video here. I will skip this video in the interest of time. Actually, you can go through this video because I'll be sharing the slide. Then QKD. So the basic enabler of our quantum AI in the next generation communication is the QKD. That is the quantum key distribution, the secret key, as I have mentioned. So basically, any plain text that will be shared from the Alice will be done through an encryptor, which encryptor will code it with the QKD basically. That is a secret key that will be shared between both the encryptors of Alice and Bob, so that Bob and Alice are already synchronized. So whenever, and that synchronization, as I told you, is done through the classical channel, and the quantum channel is used for the main transmission of the light intensities. And the beautiful thing with the QKDs is that the QKDs are constantly varying and constantly changing. So even if any attacker or Eve is sitting to wiretap the data between Alice and Bob, it cannot do it, because even if it has the full architecture that is needed to generate the quantum key distribution, still it cannot change adaptively, and thereby the code will change every moment, and it cannot hack the data. In one of the work, it is there. I'll show you. So then we should not think to move it a bit fast. We should not think here that the quantum AIML based optical wireless communication actually we should not think that the optical communications will go away when the quantum AIML comes. It is not like that. The optical communications in the wired domain, that is the optical fiber networks, will be there, and also the optical wireless network, that is the free space optical communication network, will be there. So both the systems are there, but there is always a interface between the wired network and the wireless network, and that interface is very dangerous because we have eaves or we have eavesdroppers who are sitting to constantly hack data at this portion. So what we adopt is, for this part of the channel, we develop a QKD site which will constantly generate new quantum codes switch, so that the data can be encoded using the codes and nobody can hack the data. So optical communication again is not getting replaced by the quantum communication. Rather, it is only quantum communication is only aiding the wireless communication in the optical domain. Satellite networks nowadays, as I have mentioned, are predominantly LEO networks. That is the modern day satellite communications, where all these LEO structures are actually connected with each other through these yellow bars, as you can see, or these yellow connections. So these yellow connections, K1, K2, K3, these are actually XORs of that simple XOR operations. But XOR operations of what? XOR operations of sequence of quantum key distribution codes, or QKD codes. So all the quantum satellites are connected with the ground station also, and in between them also through the quantum keys. And that is how resource allocation, very good resource allocation and very secure resource allocation, is done in the modern day satellite networks using the quantum key distribution. This is IWCMC journal that was published in the year 2020. This is one of my works where one of my students has actually worked on developing one computational offloading model, where we are trying to offload the data processing between a GNB, that is a main base station, and a RSU, that is the roadside unit. So any vehicle that is there that is traveling through the roadside in a smart city scenario, we are assuming that there will be roadside units or small base stations in addition to the major base station. So we are trying to see how much percentage of the data is getting routed to RSU and how much percentage of the data is getting routed to the main base station. And what we could found out on developing the model is that the delay is a function of the offloading probability, and at only a particular point of the offloading probability, somewhere nearby
Hello.
hello.
Sir,
Hello.
sorry to interrupt you, sir.
Yeah.
It's a gentle reminder to remind you the time. It is
Yeah, yes, sir.
7:34.
I'm just closing down in next
Oh,
5 minutes. Is it
okay.
okay, sir?
Thank you,
Yeah,
sir.
I already understand
Yeah,
that.
yeah. Okay,
Yeah.
thank you, sir.
Yeah. So this is basically the average delay and the offloading probability of the structure is a function. That packet delay is a function of the offloading probability, and it minimizes drastically only at a particular point of the offloading probability. So this is already a published work. So we could have the packet delays as a function of the packet arrival rate, and what we could understand from this structure was that at a particular point of the offloading, we could have our system optimized. This is about the network optimization or the structure optimization. So this the average packet delay, when we are moving it to the average arrival rate, we could see that we got consistent performance, and with increase in the number of RSUs, more amount of reduction in the delay was observed, and we could see our system gave a better performance as compared to all the compared other performances, the other systems that were introduced in the recent times. So we are having a fraction of a millisecond delay value. We could also have the benchmarking done with the standard IEEE benchmarking standards, and we could find that our system proposes microseconds of delay, whereas 5G proposes 1 millisecond and 6G proposes 10 to 100 microseconds of delay. So well within that, or well less than that, we are having the performance. And for the different busy locations in Guwahati, which is proposed to be a smart city, my own city, the different parameters were noted down and the delays were computed. Now we are developing a quantum AIML based model to optimize or self-optimize this particular network scenario. This is a published work at conference level, also communicated at journal. This is another work on the quantum key based distribution, where the structure of the architecture is already very clearly explained, and we could understand that already, that the photon polarization or these degrees, basically 0 degree, 90 degree, 45 degree, and 135 degree are communicated. That is, quantum bits basically means that if you have a basis of plus and 0, then the angle is 0, or angle is 90 degree. If it is plus and 1, it is 0 degree, and if it is minus and 0, it is 45 degree, and so on. So that is how the structure looks like. So we developed a key exchange method for that, and we could XOR, and we developed finally a shared secret key, that is basically the quantum key, and we could XOR it with each of the pixels of the image. And if you could see, this XORing went on in a loop, or in a XORing loop, it constantly went on over layers, so that over every layer we are able to encrypt our original image. And this is the fourth layer plane, where the entire data vanishes for any eavesdropper. And at the decryption, who has the quantum key, he will be able to decrypt and get back the original image, both in red, green, and blue plane, or the entire image as well. We compared the MSC, PSNR, NPCR, USCI performances, and found our system to be very, very stable. And also the NPCR and USCI performance was as per the IEEE format, and as per IEEE standards of post quantum cryptography P3172 structure, our system values were of acceptable range and in the given range prescribed. This was the database created, which we are working upon. QKD is also used in terahertz based communication. I am not going into the details of this, because this is core physical layer. We are trying to achieve terahertz based next generation MIMO links, where QKD is integrated with the physical layer channel, so that the estimation process could become simple, because the earlier terahertz communication used pilot signals, which lead to the spectral inefficiency, and thereby the quantum key codes were used as a substitute to the pilot keys, and the structure was developed accordingly. PLS, that is the physical layer security, I have already discussed. For authentication purpose, when there are many satellites and we have to authenticate whether a satellite that is coming in belongs to this group or it is a eavesdropper, then based on the Doppler based frequency, fingerprint we are using as the Doppler frequency, and we are trying to include the different communication, or the different Doppler based frequencies we are trying to use in the different satellite based communications. And we are trying to authenticate whether this person is a member of the satellite group or it is not a member, based on the physical layer Doppler frequency. And the last work that all of us should focus on is the generative AI based MIMO design. Nowadays, antenna design, MIMO design structures, which were purely electronics or electronics technology people used to deal with it. Nowadays, generative AI has come into the picture, so that we users can give the prompts. The generative AI will design the necessary system for all communication applications, and it will also check what are the performances for the different layers. So it was observed that without the generative AI agent, the performance of the graphs was not as per the theoretical standards, but with the implementation of generative AI, the MIMO design was much, much better, and the performance was nearly equitable with the theoretical expectations. So this is all, and in interest of time, I have two videos, but I have shown one earlier. I would leave you with I would leave you with these two particular videos. So, and you can just observe it. And with this, I am Dr. Kartika. Will there be time for just showing this 1 minute video?
Yeah.
I'm just about to wind up.
Huh?
Can I?
Yes, sir.
Yeah.
Is it? Hello?
Hey everyone, let's dive into the future of connectivity beyond 5G. We're talking about lightning fast speeds, smart networks, and even internet in
So
space.
this is what we are
Buckle
expecting
up,
by
because this is going to be a
2030.
wild ride. First up, 6G. Yep, that's right, the sixth generation of wireless technology. Expected around 2030, 6G is going to make 5G look like dial-up. We're talking speeds up to 1 terabit per second. That's like downloading 100 movies in the blink of an eye. And with super low latency, think instant responses and real-time holographic communication. Imagine having a holographic chat with your friends.
So
just
this
like
type
in
of
sci-fi
communications are to be realized by
Next,
2030.
let's shoot for the stars with satellite and space-based internet. Companies like Starlink, Amazon Kuiper and OneWeb are launching low Earth orbit or LEO satellites to provide global internet coverage. This means high speed internet even in the most remote areas on Earth. And it doesn't stop there. NASA and private companies are working on interplanetary internet, connecting Mars, the moon, and beyond. Crazy, right? But wait, there's more. AI driven networks are on the horizon, and they're set to revolutionize how we connect. These networks will self optimize, predict maintenance needs, and manage traffic intelligently. Imagine a world where your internet connection is always at its best, without any hiccups. Now let's talk about the Internet of Everything, or IoE.
IoE, I say we are trying
Evolution
to
of
connect
IoT,
everything
connecting
as
not just
compared to
devices,
IoT.
but everything around us. We're talking
Even the
smart
cup
cities,
that we have our
AI-driven
coffee
networks,
in or tea
neural
in, that will be
interface,
connected to some
brain-computer
sensor
communication,
in the
and
next
seamless
generation.
integration of machines. The future is looking pretty smart, huh? And don't forget about underwater and underground networks. 6G will integrate underwater communication, enabling smart ocean monitoring and exploration of the deep sea.
Underwater
Plus,
communications and marine
underground connectivity
communications
will
will also
include
be very,
mining,
very
disaster response, and
revolutionized
seabed
in the
exploration.
6G domain.
It's connectivity that goes beyond just the surface. Lastly, let's touch on quantum communication and computing. Quantum Internet will use quantum key distribution for ultra-secure data transfer. That means unhackable communication. And with quantum computing, we'll see real-time processing of complex data like never before. Oh, and don't forget about terahertz and optical wireless communication. Terahertz wireless will push data transfer speeds through the roof. Wi-Fi, which uses LED light for internet, will be faster and more secure than Wi-Fi. The possibilities are endless. So there you have it. The future of connectivity is mind-blowing, from ultra-fast 6G to space-based internet and beyond. What excites you the most? Let me know in the comments below. Thanks for watching, and don't forget to like and subscribe for more cool tech insights.
Okay, so with this, I would like to wrap up and mention that in 2030, whatever change we want to achieve, we should all be a part and should work on different aspects of the 6G technology in each of our domains, basically. So 6G is basically an integration of different technologies which we should work upon. So these are some of my collaborating groups, my master out students, some Indian collaborators from there. We have collaborations with the University of South Florida through my postdoctoral research as well. We also have other Indian collaborators from different parts of India, and we have connections with SDSU USA where we are carrying some research. We also have collaborators from Sri Lanka. So if anyone is willing to collaborate with our groups, with our different research activities, you are most welcome to do so. I am these are my contact details on the left, my email ID. With my, I am available on LinkedIn, ResearchGate, Google Scholar. I extend my special thanks to the director of VTIAS of Erode. Special thanks to Madam Dr. D. Kartika for the invitation, who is the HOD of Computer Science at VTIAS, all the organizers of this international FDP, all members of IQAC and School of Computing, VTIAS. I am thankful so much for this opportunity to deliver the lecture. I hope I have been able to do some justice in terms of delivering to the expectations of this FDP. I also apologize for overshooting a little bit over the time. However, I hope it was in interest of the greater learning of the research community. Thank you. Any
Any
questions?
questions?
Thank you.
So
Yes,
thank
madam.
you,
Yes, madam.
thank you so
I
much, sir.
hope it was
I
okay.
really
It
Sorry
was
for
okay.
enjoyed.
over.
Sorry for over.
It was really a good session where you cover WSN, quantum, AI, ML, all the things. I hopefully this session would be an eye opener for all the researchers who have joined today, for who want to do their research in quantum.
Yes, madam.
Yes,
So I'll share your mail ID and contact if they have any queries, and if the people want to join you for the research collaborations. I'll just share your details with them. And thank you for joining us for the session, sir. It was a neat
Definitely. We had one
preparation
query.
from the starting till the end.
Yeah.
It was a very neat preparation. Thank you for it, sir. You have
I think
anything to
we had
say,
one
sir?
query that I had got in between. If that person is still there, we can take that query.
Participants, do you have any queries? Like your session is open up for the queries. MC team, you can start with the vote of thanks.
Thank you.
Thank you, sir.
As we come to the conclusion of this session, now I would like to welcome Ms. Gopika from 2nd CSA for a vote of thanks.
Good evening, everyone. As we conclude this enlightening session, it gives me great pleasure to deliver the vote of thanks on behalf of the organizing committee. The first standing foremost, our deepest gratitude to Dr. Satyasati Bhattacharya for his brilliant discourse on integrating AI/ML and quantum technologies with next-gen wireless communication systems. Sir, your insights have been thought-provoking and your ability to interlink emerging technologies with a practical communication framework was truly inspiring. We thank the internal quality assurance cell and the School of Computing for their leadership and collaboration in organizing this impactful faculty development program. A sincere thanks to our technical team, faculty coordinators, and the support staff who have worked tirelessly to ensure today's event was conducted smoothly. And last but not least, to all our participants, thank you for your active involvement and the eagerness to learn. Your patience for results is what drives the success of programs like this. We now look forward to continuing this academic momentum in the session to come. Thank you all once again. Have a wonderful day.
Thank you.
Thank you,
Thank you.
sir.
Thank
Thank
you,
you.
ma'am. Thank you.
Thank you, sir.
You can leave the session, sir. Thank you
Yeah,
so
ma'am.
much.
I'll be leaving the session. Thank you. Thank you, ma'am. Good night.
Thank you.
Thank you, madam.
Good night.
Thank you, sir.